In this video, we are given a situation for which we are to write a division problem given those conditions. After writing the division problem, we are to calculate the results. And if the problem ever involves a negative number, all negative numbers in the division problem that we write must be written so that they have parentheses around them. It is very important to note, however, that you do not put parentheses around a negative number in the calculated result part of the question, or you will be marked wrong. And also note that to get a division symbol on the computer, if you're typing this into MathEssay, you would use the key on your keyboard that looks like this to represent division. And if you want to find that on your keyboard now, this should be the key just to the left of the shift button that's on the right side of your keyboard. Now that we know the directions, let's look at the specific example given. We are to write a division problem with a divisor of -9 and a dividend of 63. So a divisor is the number that you are dividing by, and your dividend is what you are starting with. You can think of the dividend of 63 as the number you're starting with, and then we are dividing that by some number, and what we're dividing by would be the divisor, and they want that divisor to be -9, and as stated in the direction, any negative numbers that you write, you should put parentheses around them to get credit for the problem. So in MathAS, if you were doing this problem there, you would write 63. You would use the symbol on your keyboard that looks like this, just to the left of the shift key that's on the right side of your keyboard. Left parenthesis would be shift 9. To get a negative key, look to the right of the 9 that you just hit. You'll see a 0, and then just to the right of that, you'll see a button that looks like this. And if you hit that, you should get a negative symbol. Then type 9, and then to get a right parenthesis, hold shift and press the number 0 on your keyboard. And this should be the correct answer to the division problem. To calculate the result, let me remind you that the meaning of this statement, 63 divided by -9, means how many copies of 9 things does it take to make 63 things, and then you also have to pay attention to the sign. So imagine that we have 9 negative chips, so think of this number as the number of objects that we have in each copy, or if you'd like to think of it as the number of objects in each group, that works as well. And we want to know how many copies or how many groups of these 9 objects would it take to get a total of 63 things. So the idea is we want 63 objects, and we're going to get those 63 objects by counting many groups of 9 things. If you like the chip model, -9 can be thought of as 9 negative chips, and the idea would be how many copies of these 9 negative chips would it take to make 63, and 63 is positive, so you'd think of that as 63 positive chips. So it turns out there's no way to put together many negative chips to get 63 positive chips. So what we do is we'll use these chips anyway, and we'll just figure out how many groups of 9 things, so disregarding the sign, how many groups of 9 things does it take to make 63 things. So if you took the time to make several copies of 9 negative chips, counting up as you went how many you had, you wouldn't get to 63 things until you got to actually 7 copies. So here's my second copy of 9 things, 3, 4, 5, 6, and 7. So it took 7 groups or 7 copies of 9 things to make 63 things. Now the problem is that we used 7 groups of 9 negative chips to make 63 things, but those 63 things were supposed to be positive chips because the number 63 is positive. So to compensate, you think of this as it took 7 groups of 9 things to make 63, but because we were using negative chips and we were supposed to get 63 positive chips, we had to use chips of opposite sign to get our goal. So our answer to the final problem should be the opposite of this answer, which would be -7. So it turns out that 63 divided by -9 comes out to be the opposite of 7. It took 7 groups of 9 things to make 63 things, but the things in the group were opposite in sign of what my goal was, so I have to change my answer from positive 7 to the opposite of 7. Let me show you the rules in general for dividing signed numbers to make this process a little simpler. Here are the rules in general for dividing signed numbers. They actually are exactly the same rules as for multiplying signed numbers, except in this case we're dividing. So if you're dividing two numbers that have the same signs, your answer would come out positive. But in this case, we had the case where our numbers were opposite in sign. One was positive, one was negative. We had a positive 63 and a negative 9, so the numbers we were dividing had different signs. And when that's the case, when your numbers have different signs, your answer will come out negative. And it's exactly what I just showed earlier, that a positive divided by negative came out to be negative. Then perhaps the harder part of the problem is how many copies of 9 things does it take to make 63? And we argued that already and came up with 7. So I'd like to do another problem. This one says negative 45, and again, you were to put parentheses around any negative number in the division problem. Negative 45 divided by, so we would put a division symbol. So literally translated, negative 45 divided by negative 5. I'll put that here. This would be the division problem, and you would have to use parentheses around both numbers because they are negative. Just remember that on your keyboard, you're using the symbol that looks like this for division rather than this one. So this is how it should look on your computer screen when you type the answer in for the division problem. Now the actual calculated result, there's actually two different issues. We have to know what 45 divided by 5 is, and then to take care of the signs, just notice that this number's negative, this number's negative, so they have the same signs, and if they have the same signs, the answer to the problem should come out positive. So I already know my calculated result is going to be some positive number. Then to find the rest of the answer, you needed to know what 45 divided by 5 is, and disregard the sign because we already took care of that. So 45 divided by 5 could be thought of as you have 5 positive chips, or if you want 5 of anything, and you want to know how many copies of the 5 things it would take to get a total of 45. So in a division problem, the first number is the total, and this is the number of objects in each group. And the answer to the problem would be how many groups or copies would you have to make to get that total. So how many groups or how many copies of these 5 things would I have to put together to get 45? You could keep copying several copies of 5 positive chips, or you can think of it as every time you make a copy of 5 chips, that would add 5 to the total. So if I made another copy, a second one, rather than thinking of it as a second copy of 5 positive chips, you could think of that we just added 5 more to the total. So the question can become, how many 5s do I add together to get 45? So because I'm running out of room, I'll start up here. Here's one 5. Here's a second 5. That would be 10. 5 more would be 15. 5 more would be 20. 5 more would be 25. 5 more would be 30. 5 more would be 35. 5 more would be 40. And 5 more would be 45. So if you can count by 5s, this would be 5, 10, 15, 20, 25, 30, 35, 40, 45. So if you count the number of 5s it took, 1, 2, 3, 4, 5, 6, 7, 8, 9, it took me 9 copies of 5 to get a total, meaning add them together, of 45. So because 45 divided by 5 is 9, meaning that it takes 9 5s to make 45, gives me part of the answer. The rest of the answer was just found by saying that the signs on the two numbers were the same, and whenever you divide two numbers with the same signs, the answer comes out positive, so I'd leave my calculated result a positive 9. In this problem, it says, how many times does negative 3 go into 21? So we're taking 3 and dividing it into 21, and what this means is that we want 21 as our total, and we're wondering how many times does negative 3 go into that, meaning how many copies of negative 3 would it take to make 21? So as a division statement, we could think of it this way. To know how many copies of negative 3 it takes to make 21, we are saying how many times does negative 3 divide into 21? And you would start by just ignoring the signs and first doing the problem 21 divided by 3, meaning how many 3's, or how many copies of 3, does it take to make 21? And again, if you can count by 3's, you can sit and say, every time I add 3, I'm making another copy of 3. This would be the equivalent of writing 3 positive chips and saying how many copies of 3 positive chips would I have to write down until I had a total of 21 chips. Rather than writing down these symbols to represent positive chips, you could instead write the number 3. Here's 3 positive things, here's another copy of 3, here's another copy of 3. Let's count by 3's and see how many of 3's we'd have to add together to get 21. The first one would be 3, 3 more is 6, 3 more is 9, 3 more would be 12, 3 more would be 15, 3 more would be 18, and then 3 more would be 21. So if you added these 3's together, you should get 21. And then the question is, well, how many copies of 3 did I have to make? 1, 2, 3, 4, 5, 6, 7. It takes 7 copies of 3, or it takes 7 3's being added together to get a total of 21 things. So what that gives me is the number 7 is the answer. So my calculated result will involve the number 7. Then to figure out whether the answer to my problem should be positive or should the answer be negative, I look to see if the signs on the original 2 numbers are the same or different. The original problem was a positive 21 divided by a negative 3. That's positive, that's negative, means they had different signs, so the final result should come out to be negative. So my calculated result should be negative 7. And it turns out, if you go back to the directions, that the answer to the calculated result portion of the problem, if it's negative, you do not need to write parentheses. In fact, if you put parentheses around the negative 7, the current question that I tried this on marked me wrong. So if you go back to the directions, they actually say this. They say place all negative numbers in the symbolic form in parentheses, meaning you don't have to do that and shouldn't do that in the part of the question where they ask for the calculated result. Only place negative numbers that in the symbolic form of your answer in parentheses. One last problem I'd like to do is how many copies of 5 are in negative 15? So again, if you remember that in division we organize things so that you have some total and then you divide by the number of objects in each copy that you are going to make, and the answer to that division problem would be the actual number of copies that it takes of those objects to make the total. So when we say how many copies, they're asking for this right here, how many copies of 5, so that would be the number of objects in each of my copies, so that goes here. How many copies of 5 objects are in negative 15? So we want the total to be negative 15, and since this is the division problem, so make sure you put parentheses around the number negative 15 because this is the answer to the division problem, except you are not to write the equals question mark. So to do my division problem of negative 15 divided by 5, the calculated result would simply be that the signs are different. One's negative, one's positive, so my answer is going to be negative, and you don't need parentheses around a negative result in the calculated results portion of the question. Then the question is how many 5's does it take to make 15? This is actually pretty simple because the number 15 is so small. It takes 3 5's to make 15. 5 plus a second copy of 5 makes 10, a third copy of 5 makes 15. So it takes 3 copies of 5 things to make 15, so the answer would simply be 3, but since the signs were different, the answer to the final answer is negative.